Hi, I am Dr. Gökçe. With this video, I would like to introduce you to our electric motor specifically developed for electric vehicles. Um, this electric motor also it's an integrated system specifically developed for A-class city cars, small type city cars. But this integrated system can be scalable to upper car classes like the sedan or SUV type of classes. When we look at the basic specifications of this integrated system, in the system we are using an PMAC, permanent magnet alternating current electric motor. It works with 110 volts and it has a relatively high speed. It can spin up to 15,000 RPMs. The power of the electric motor is 44 kilowatts. It's the maximum peak power output, and the continuous power is around 24.5 kilowatts. As I mentioned, it has 15,000 RPM, so it's relatively a high speed. There's a reason behind it. We would like to keep the system as compact as possible. Also, we would like to keep the system weight as low as possible. So in order to achieve this, and if you want to achieve your targeted power ratios like 44 kilowatt power, you need to keep the speed as high as possible. And of course, this high speed levels has helped us to achieve our power targets. Simultaneously, we keep our dimensions and total weight as low as possible. And with this low weight and compact size, we managed to eliminate the negative effects of unsprung weight, which is the common complaints of in-wheel type of electric motors, which negatively affects the handling and car dynamics. So keeping this weight as low as possible and also the design as compact as possible, we mainly eliminate the negative effects of unsprung weight. The electric motor alone has a 95% of efficiency. Of course, in the integrated system, we have a transmission and brake system integrated as an overall electric vehicle system. And when we look at the system efficiency, it is around 91%. Also, including the transmission and the brake system, the system wheel output has a kind of 350 Newton meters of torque at the wheel as a system. In order to achieve these figures, we used an adjustable transmission, which is 1 to 11 and 1 to 16 levels. It is adjustable between these for this transmission system. When we briefly look at the brake system, we use an off-the-shelf component from Brembo. It's a famous and international brake manufacturer from Italy. And in this brake system, ABS and the handbrake is already integrated within the brake system itself. When we look other advantages of the integrated electric motor system, we used composite wishbones, which is carbon fiber composite wishbones. These are not only connecting the electric motor to the car chassis, but also acting as a coil system, which is a mandatory or a must in the overall amortization system of the vehicles or cars. So by using this flexible carbon fiber composite wishbone or wishbone design, we managed to eliminate the suspension coils, and it gave us around 10 to 15 kilograms of weight savings. Again, for the suspension system, we use an off-the-shelf suspension part from Swedish manufacturer Öhlins. And also, in order to connect the system to the car chassis, we designed and developed adjustable rods and adjustable chassis connection points, which makes our integrated system flexible for different brands and different vehicle types. So if you want to use this electric motor system in an, let's say, city car, you can use it, but if you want to upgrade it for a sedan or SUV type, you don't need to change the overall design completely. By using the adjustable rods and adjustable connection points, you can easily adapt the electric motor system for different types, different brands. The electric motor casing has a full protection against water and dust. So in more specific terms, it has a protection level of IP51, which is international protection marking 51. This is relatively a high protection level, which is internationally recognized against the liquid and dusty objects. So we have this full protection. When we look at the overall system weight, our electric motor itself weighs around 10 kilogram. Our transmission system is weighs around 12 kilogram, and the brake system and the connection points is around 3 kilogram, and we are talking about an overall system weight of 25 kilogram, which is relatively low when we compare it with the available systems in the market right now. This is also an important point. We are using samarium cobalt permanent magnets instead of neodymium iron boron permanent magnets. There is a reason behind it. Although neodymium based permanent magnet has higher efficiency rates, but it's a kind of rare element, and it is difficult to supply, especially from China. Now the Chinese government has a kind of export limitations for these kind of rare earth elements. Therefore, our decision in the electric motor is using the samarium cobalt permanent magnets. These samarium cobalt permanent magnets has some drawbacks, of course. When we compare with the efficiency issues, it's not that different from the neodymium based magnets, but the samarium magnets has a tendency to break down, but in our initial design phase we just took this into consideration and just improve our designs by taking into consideration this issue. Also, these magnets losing their magnetic powers when the temperature gets higher. So in order to avoid it, our system and electric motor has a very efficient liquid-cooled system. So with this efficient liquid-cooled system, we eliminate this high temperature issues, and we minimize the risk of diminishing power in the magnetic force. And yes, I think these are the most important and critical factors of our design. We are still working on it to improve the efficiency and also just try to reduce the weight as much as possible. But up to now, we have a very satisfactory results. I hope that our hard-working engineers and our R&D team, we will achieve better results, more improved results in the near future. So thank you very much.